Hey everyone, and welcome to our first video lesson. This is 1.1, solving equations. So the first skill we're going to need in solving equations is to just refresh our distributive property. Okay, so we know distributive property, whatever values are on the outside of the parenthesis, okay, we're going to multiply those in. And we're going to carry through our signs and operations, meaning a positive 3 times a positive 7 gives me plus 21. So we no longer use double signs. We want to figure out that multiplication in our head. We're only going to put down one operation. Okay, so double signs means like plus negative 10. We don't want to see that. So negative 5 times x gets you a negative 5x, and times a positive 8, well, now that's going to change and be a minus 40. So we see in both those first two examples we don't have any like terms, because an x term and a constant term, that's what we call just a number, those cannot be combined. Right, example 3 has a little bit more meat to it here. So the negative 4 is actually doing multiplication, okay? And in order of operations, multiplication comes before subtraction. So that means we do not want 8 minus 4, okay? We want distribute the 4. That should be our first step. So in the meantime, we're just going to carry through the 8. After we distribute, okay, we have a negative 8x minus 20. Well, looking at these, I have like terms. So using whatever notation you want, okay, you should be indicating which are like terms. So I've used 3 underlines here. You can use a squiggle, a box, a circle. Okay, it's up to you, but you want to make sure that you're indicating. Okay, so I like to put my variable first. I'm going to carry over the negative 8x and then combine 8 minus 20. Is negative 12. That is my final answer when all terms have been combined. All right, in this last example, 2 is being distributed, and then this negative 3x on the end, it's not inside the parentheses, so it does not get multiplied. That's what I like to call a caboose. Okay, so we have another 2-step problem here. So 2x minus 14 from our distribution, we carry over the negative 3x, and then we can combine like terms. So negative x, because it's 2 minus 3, minus 14. All right, so now that we have some distributing done, we can go ahead and move into our examples. So this is a pretty simple one. You've got some distributing, but there's only one variable on one side of the equation. Okay, so we're always going to start, our first step is to distribute. Okay, so this gets me a negative 12x. This becomes plus 8, a negative times a negative. Now we are ready to solve at this step. When we solve, we use order of operations in reverse. That's called SADMAP. So subtraction and addition are going to be moved first. So I have a plus 8. Okay, also remember that you're using opposite operations. So if something is being added, in order to move it to the other side, we're going to use subtraction. I want to see every step of work. So I want to see the minus 8, and you're showing that it's being subtracted to both sides. We use this nice long line underneath to separate each step of work. Okay, so the 8s should cancel. Negative 12x equals 48. Okay, the negative 12 and the x are multiplying, so the opposite operation there is division. So we're left with x equals, watch your signs, positive divided by a negative. Okay, and we know in order to check our work, we're going to take what we think is our final answer and plug it back into the original problem. You want to use parentheses, and especially in this case, when the value for your x is a negative. Okay, so evaluating each side, we want to make sure that we get a true statement here. So a true statement is when both sides of the equation show the exact same thing. All right, so we get 56 equals 56. So that means this answer is good. -4 is our final answer. Okay, let's try one that's a little bit more complicated. So now it looks like I have variables in two different places. I still have some distribution. Okay, so remember, distribute is always our first step. This -x is just going to carry down since it is not being multiplied in. All right, and now we're going to combine like terms. Okay, so indicate what are like, and this is -10x minus 6. All right, now we're ready to solve. We're going to use opposite operations. So I'm going to add 6 to both sides. And now divide by -10. Okay, and watch your signs again. All right, and then you want to make sure that you check your answer. You don't have to show your check by hand. You could always plug it into the calculator, but you definitely want to make sure that you're checking because this is a very simple type of question to make sure you get correct. All right, let's keep going. So now we really have to think about this one. So we want to figure out, well, what operation is each term doing? Okay, so if we don't realize that the -6 is distributing and that is always our first step, well, then hopefully we can see that 2x and 6 are not like terms, and so we could not even put them together anyway. All right, so bring down the 2x, -6x plus 12. The 7 is a little caboose, bring that down. Okay, now we definitely have some sets of like terms over here. All right, however you want to indicate, but make sure that you do show. So this becomes -4x. This is 19. Okay, and now we are ready to solve. And we have our final answer, x equals 5. All right, doing great so far. Okay, now this is different than what we've seen before. I have a variable on each side of the equation. Okay, so if we had any distribution, we would do that first. Okay, since we do not, and there's no like terms, okay, because that would be step number 2. We want to move, and this is just a rule of thumb. It's not the law by any means, but we always want to move the smaller variable to the larger one, okay? And this is in reference to when they're on opposite sides of the equal sign. So by moving the smaller one, it doesn't give us a 100% guarantee, but we have better shot of avoiding negatives. Okay, so if the 3 is positive, we can use subtraction to move it to the other side of the equation. So 6x minus 3x. Okay, this is going to cancel from the right side. So now all of my variables are on the left, and now I can continue to solve. Okay, and we get x equals 3. Great. Okay, so again, another situation where I have variables on both sides. So if I'm looking between a negative 4x and a 3x, okay, think to yourself, well, which one of those is the smaller variable? It's actually the negative 4x. And we can use addition to move it to the other side of the equation because we have to get the variables all in the same place in order to solve. Oops, that's a 2, not a 12. Okay, so from here, this is just a two-step equation. I can add 2 and divide by 7. Okay, now at this step of the problem, if you don't like having the variable on the right side of the equation, you can just flip the entire thing. Okay, exactly as the signs and everything appear, you can just put them on the opposite side of the equal sign. Okay, and so this would be fine as well. That's just if you like having your variable on the left. Okay. All right, definitely making this a lot more complicated now. We've got variables everywhere. We've got distributing. Okay, so we're going to put all of our steps together in one problem. So I'm going to distribute first. So 3x minus 24 minus 5. That's on the left. Okay, on the right is 9x plus 18 and plus 1. So remember that negative 5 and that 1, those are just getting carried down because they are not inside the parentheses to distribute. All right, now we're going to combine like terms, but we do it separately on each side of the equation. So if you want to put a line down your equals, okay, in order to keep this divided, okay, this is usually the step where errors could occur. So we only combine on the same side of the equation. When you start moving to different sides, that's actually considered solving. All right, so on the left, negative 24 and negative 5 are like terms. And 18 and 1 get me 19. Okay. All right, so now I'm going to move the smaller because I have variables on both sides. So I'm going to use subtraction to bring 3x to the other side. Okay, and I can start to solve now. So subtract 19. Okay, negative 29 minus 19 gets negative 48. Divide by 6. We're going to watch our signs here. So that should be a negative 8 for our final answer. Okay, remember, always check your answer, plug it back into the original on both sides now because you have an x on both sides, and use parentheses. All right, couple more here. So I see parentheses, I'm going to distribute. So 30x minus 18. And now this 1/3, okay, I'm going to distribute a fraction. It's not a big deal. Okay, so multiply across the top and across the bottom. It would be 24 over 3, which is 24 divided by 3. Okay, that's an 8x. And then this becomes plus 4. Okay, easy peasy to deal with fractions here. So now variables on both sides. I'm going to subtract 8x, move the smaller one. Okay, and then I can begin to solve. So add 18. 22x equals 4 plus 18, 22. and divide. X equals 1. Okay, remember 22 divided by 22 is not 0. You're dividing, not subtracting. Okay. Just going to keep going here. Best way to get better at solving equations is just practice. Okay, you could even pause the video and try this on your own and tune back in once you have an answer. See if you were right. All right, so I've combined like terms. I'm going to move my smaller variable. And begin to solve. All right, so I get 35x equals 0. The problem is not broken. Do not stop here. We can continue to solve. I can divide out that 35. 0 divided by 35 is 0. Okay, do not leave this as 0 over 35. That's not a final answer. Okay, quick little trick here. 0, okay, divided by any number, we can call it k. All right, that's okay. But a number, call that n, divided by 0, that's no. All right, easy way to remember. All right, last thing we have up for today is our special cases. Okay, so I have two different scenarios here. I'm going to begin solving, okay, just like we have this whole time. So I'm distributing, combining my like terms. Okay, and now I have a variable on both sides. So the rule says we'll move the smaller. If they're both the same, I guess it doesn't matter. So I'll take this one that's on the left and I'll move it to the other side. So I'll use subtraction. So this cancels. So 5 equals 5x minus 5x. Well, that's 0x. That cancels out. Don't write 0x, by the way. That just cancels. So the variable is all gone. Well, and I'm in this weird situation now. 5 equals negative 12. I don't really know what to do with that yet. All right, so I'm going to leave that. I'm going to look at my second example. Okay, distribute. There's no like terms. But again, I have the same variable to try and move to the other side, so it doesn't seem to matter. Get rid of that one. This cancels again. So negative 3 equals negative 3. Well, it's sort of like the first example. At least it's a little bit better because I have the same number on both sides. So what does this actually mean? Because neither one of these are not actually final answers. I can't leave this. So let's make a note here. Not a final answer. All right, so let's see, what does this mean? All right, so these two situations could possibly mean no solution or all solution. Okay, it depends what kind of statement you get at the end. Okay, so statement, those are the key words. So a false statement is when I get down to the end of my problem and it doesn't make sense. 2 equals negative 5. 2 does not equal negative 5. These are false. Okay, false. Does not make sense. Okay, not equal. Well, the final answer in that situation would be no solution. Okay, and then the flip side to that is a true statement. So when you get something that makes sense, the same number on each side, 0 equals 0, 2 equals 2. Okay, so a true statement, they are equal. Okay, your final answer that you would write down, because you wouldn't just leave 0 equals 0. Your final answer is all solutions. Okay, so no solutions means that there is no number that will make sense to make each side of that equation the same. All solutions means you could pick any number that you could think of, plug it into your equation, and both sides would be equal. Okay, so if we go back here for a second, all right, we can label each one of these examples. So our first one, my final answer, would be no solutions. And my second example here would be all solutions. Okay, because this is false, because 5 does not equal negative 12, and this guy is true. Okay, because negative 3 equals negative 3. All right, so I hope that you took notes on all of this. Okay, if you need to rewind, pause the video, go ahead and do that now. Okay, write down any questions that you have for our next class. Right, and thank you for watching.